A community member requested that I explain this exercise in my own words. This is not an easy question. Before we dive in, please subscribe to the channel, like the video and share it with others. Do not forget to turn on the notification bell so that you won't miss any updates. I would appreciate it if you could share the channel with your friends. Thank you very much. Figure below shows a mobile bird sculpture that has been created by an artist. M is the center of mass of the bird sculpture, including its tail, but not including the counterweight that will be added later. The mass of the bird in total is 1.5 kilograms. The bird sculpture is placed on a pivot. The artist adds the counterweight at the end E of the tail so that the bird remains stationary in the position shown. Item A. Calculate the mass of the counterweight. To solve this problem, we apply the principles of torque and equilibrium. The moment of a torque is the turning effect around a pivot point, calculated by multiplying the force's magnitude by the perpendicular distance from its line of action to the pivot. The moment of a force is also known as torque. The bird sculpture must be balanced around the pivot. The total torque on the pivot is zero, which means the clockwise moment must equal the counterclockwise moment. The distance from the pivot to the center of mass of the bird sculpture is 12 centimeters, and the distance of the counterweight is 30 centimeters. The torque due to the counterweight is given by the product of its mass, the gravitational acceleration, and the distance from the pivot. The torque due to the bird sculpture is given by the product of its mass, the gravitational acceleration, and the distance from the pivot. The solution of this equation reveals that the mass of the counterweight is 0.6 kilogram. Item B. The center of mass of the sculpture with counterweight is at the pivot. Calculate the upward force acting at the pivot. To calculate the upward force at the pivot point in a system at translational equilibrium, sum all downward forces and confirm that the total of all forces acting on the object equals zero. The sculpture is rotated clockwise to the position shown in figure 2.2. It is held still, then carefully released. State whether the sculpture will stay in that position, rotate further clockwise, or rotate back anti-clockwise. It stays in position because it is balanced. Explain your answer. If the sculpture does not rotate when in the first position, it indicates that the clockwise and anti-clockwise moments are equal. Torque is calculated by multiplying the magnitude of the force by the perpendicular distance from its line of action to the pivot point. When you rotate the sculpture, you reduce the perpendicular distance between the weight and the pivot. These distances decrease proportionally, ensuring that, in all cases, the clockwise and anti-clockwise moments remain equal.